There we go. I think we're recording now. Okay, so like I said, today we're just going to go over some homework from 4.2, 4.3. So the first question I picked here was this guy here. Oh, that didn't work very good, did it? There. This guy here, and the reason I picked this is somebody asked about it because they disagreed with the answer in the back. So first of all, what's your absolute maximum? Well, your absolute maximum happens here at x is 1, 2, 3, 4, right there at x is 4. So my absolute maximum happens at, well, let's see, the way that the answer key gives the answer is they'll say that it happens at f of 4 and that it equals. I think, let me just double check, but I think that's the way they give answers in this book. Yeah, so they'll say f of 4, and they say that it's 5, even though it very clearly, when you look at it, doesn't quite make it all the way up to 5. I think they're just rounding it to the nearest integer. So you can say, if you said that the answer was x equals 4, or if you gave me the point 4 comma 5, I'm fine with all of those. The absolute maximum value, the way they say the question, the absolute maximum value really at the end of the day is the 5. Right? It's the y coordinate of the answer. But any of those three answers tells me that you understand what's going on. So I'm not too terribly worried about it. So the absolute minimum value is down here at x equals, so again, the way the textbook gives the answers, they'd say that it's f of, let me count that, -1, -2, -3. So they'd say that f of -3 is where it is the minimum value, and the number for that value is, what is that number, -2? And let me just double check again, but I think that's the way they give the answer for that. IIA, yeah, that's the way they do it. And then for C, I had somebody ask, well, why don't they consider this a local minimum as well, or sorry, I guess maybe this one. Why don't they consider that one a local maximum as well? Isn't it also a local maximum? Yeah, but once you've called it the absolute maximum, you don't have to rename it again. I'm fine with you if you listed this as one of your answers for C as well as for A, I'm fine with that. You're not wrong. A point can be both a local maximum, and if it's bigger than anything else in the whole question, it's also an absolute maximum. That's fine. It's really easy in this chapter to get kind of tripped up in the semantics of definitions that not everybody in the world even agrees on. For our purposes, I'm happy calling this either the local maximum for this interval of the graph or the absolute maximum for the entire graph. In A, it specifically asked for an absolute. That's the only answer that you can give. For C, when it asked for local ones, well, you could give me this one, which is, I think, the answer they give, right? They'll say that f of 1 is, what is this point? 1, 2, 3, 4. So 4 is the value we're looking for the local maximum. And it's fine by me if you included this point as another local maximum. The book doesn't bother because they figure, well, we took care of that point back in A. Then here's the other question I got about this question. How come they didn't include this point? Isn't that a local maximum? And the answer is yes, you could consider that a local maximum. Endpoints can be considered local maximum as well. But I think the logic of the reason why the book doesn't include that is because since the function doesn't seem to exist past this point, we don't know what it would do if it was unbounded. In other words, does it continue like that, in which case, yeah, that's definitely a local maximum. Or if there was no boundary on it, would it continue like this? We don't actually know what it's doing after that because the thing doesn't exist after this. So they don't bother calling it that. And you might be saying, well, then why did they call this the absolute minimum? And that's, you know what, that's actually a really good question. I'm not 100% sure why the book goes that way. But this is definitely the lowest possible point that the graph can go, so they call it the absolute minimum. Notice they don't call this a local minimum either. So the only local minimum that they give you is they give you these two here. These are your two local minimums, right? So that'd be f of, what is that, 2, which is 2, and f of 1, 2, 3, 4, 5, 6, f of 6, which is 1. And I think, let me double check, I think they give them both, right? Yeah. So f of 2 is 2 and f of 6 is 1. So it gives you two local minimums. So the question I had is, well, why don't they give us two local maximums and count this one? And I guess they just don't count it because it's an endpoint. But personally, I don't think it's wrong to count it. I certainly wouldn't mark that wrong on a test. Okay, so that's all I wanted to talk about for number one, because I had a couple people asking about it. After that, and again, feel free to put a question in the chat or turn on your microphone and ask a question if you have any questions. After that, I wanted to talk really quickly about 3G. 3G is the type of question where you don't have to do any algebra whatsoever if you're 100% sure you know what the shape of this thing is. It's a huge advantage to understand the shape going into the question. So looking at G, I wouldn't do any work for G. I just happen to know that the absolute value of x, hang on, the absolute value of x, come on pen, oh hang on, now my pen's doing weird things. Okay, hang on, sorry, this will only take me a sec. Sometimes all that needs to happen is this needs a bit of tightening. Let's see, did that help? Not quite. There we go, we're back. Okay, so the absolute value of x is this V shape here, right? So that's the y equals the absolute value of x. So the absolute value of x plus 6 just shifts this thing 6 units to the left. So right there, where that's 6, 5, 4, 3, 2, 1, 0. So you know that this thing's continuous forever. There's no place on here where the slope's going to be 0 or undefined. It's continuous forever this way. There's no place where the slope's going to be 0 or undefined. So you know that critical numbers and critical values, same thing, critical points, are only the points where the slope is 0 or it isn't defined. So there's never going to be a place where the slope's 0 because this thing doesn't turn around again. And right here is the only place where the slope's undefined. So you don't need to do any algebra. I had some people who asked about G and said, well, how do you know what to do to find the derivative when there's an absolute value? And I said, well, we actually did show you earlier in the course how to deal with the derivative of the absolute value of x. So if f of x equals that, there is a way. Look back in your notes. There is a way to do that. But in this case, I don't think I'd even bother. I know what the critical point is. It's the point where the slope doesn't exist because it's a cusp right there. So that's it. The critical number is x equals 6. Sorry, negative 6. So that's it. I would just use kind of logic and common sense based on what I know this graph looks like. A question like J is more the kind of question where, okay, I've got to do a bunch of calculating. This one takes some work. So this one, I honestly am not quite sure what the graph of that looks like. So the first thing I'm going to notice about it is I'm going to notice, I'll even write it down here, note, this function doesn't exist if x is less than 1, right? Because you can't square root a negative. So that means that that's going to come in kind of later. First thing I'm going to do with it is I'm going to turn it into a form where I can do a derivative of it. Let me write a little prettier here. There we go. That makes a little more sense. And then I'm going to use my product law. So product law to find the derivative is the derivative of the first thing times the second thing plus the first thing times the derivative of the second thing. And that's kind of ugly to work with, so I'm going to maybe put it back into radical form and deal with that negative power. So this x stays in the numerator, this 2 is the denominator, and this factor here is denominator. We've seen this lots of times. And I think I'm even going to combine this into one thing. I'm going to multiply the top and bottom of my first term by that denominator. So I'm going to get 2 times square root of x minus 1 squared plus x all over 2 times root x minus 1. And again, we've done algebra like this quite a bit this course. So that square root and square is going to cancel, and I'm going to get 2 times x minus 1, which is 2x minus 2 plus x all over 2 root x minus 1. And here, let's finish that off over here. So y primed is equal to 2x plus x, which is 3x minus 2 over 2 root x minus 1. Okay, so now that I've got a derivative, where are my critical values or critical numbers? They happen when the slope is either 0 or it doesn't exist. So where is slope 0 or does not exist? Well, the slope doesn't exist if I'm dividing by 0, obviously. So x equals 1 is a critical point. That's my not existing one. And I can set the slope to 0 to find the other one. And setting the slope to 0 makes this algebra much, much easier to deal with because now I can just multiply both sides of the equation by the denominator. And boom, I get that. So x is equal to 2/3. And that's it. That's the answer that they give. Therefore, my critical values are 1 and 2/3. Now, it asks for critical values. It doesn't ask for critical points. If it had asked for critical points, I'd have to take this x as 1, go back to the original equation and plug it in and find out that it's in fact 0. So if it had asked for critical points, if it had said critical point, I'd say that it's 1, 0 is one of my points. And what happens to this thing when x is 2/3? I don't know, I'm going to have to figure that out. What's 2/3 times the square root of 2/3 minus 1? That'd be, oh, hang on a sec. Isn't this interesting? That doesn't even exist. So interestingly enough, that's the only critical point, even though there are 2 critical values. And you might be asking, and somebody did ask me this, which is why I picked this question, what's the point of saying you have a critical value somewhere where the function doesn't even exist? Well, remember that it doesn't exist in real numbers. We're setting you up for post-high school where it's not going to be the biggest deal in the world that you have to square root a negative. There's an entire system of numbers, an entire branch of mathematics dedicated to working with square roots of negatives. For right now, though, this point here doesn't actually exist. So it's a critical value for a point that doesn't exist on the graph. So as far as we're concerned, those are my critical values. But if it had asked you for critical points, there's only one of them. And just to kind of highlight that, and I encourage you to do this all the time. No, I don't encourage you to bring up this text box. Go away. I encourage you to check these out on Desmos when you're working. So have I opened Desmos yet today? No, I guess I haven't. Sorry, give me a sec, Desmos. And come on, Desmos. Come on, don't make us wait. There we go, we're logged in as me. I was playing with this yesterday, so it should be there. Yep, oh no, there it is. 4.2 and 4.3 homework questions. So here we go, so yeah, so there's the first one, right, where I just kind of knew what that was. Right, it's just right there, okay, so that was the first example I did. And then this example right here, right, it doesn't exist past x is 1, right? So that can be the only critical point that exists, even though 2/3 or whatever is in fact a critical value, okay? I already have picked which questions I'm going to do, so 3D I don't think is one of the ones I was going to do, but I could do that for you another time if you like. Okay, so I'm gonna move on to other ones that I've already had people message me about. Okay, so where are we at? So the next one I was going to bring up is number 4 in 4.2, and it's 4f. Find the absolute maximum and the absolute minimum of that function. And notice this function's bounded. So here's how we got to do this one. This is a big crazy one. So I know x to the power 5. I know that those things are continuous graphs. They go down forever that way. They go up forever that way. They could change directions up to 4 times. But it's going to be continuous. There isn't going to be anywhere where there's an asymptote or a cusp. So I don't have to worry about anywhere where the slope doesn't exist. The slope exists everywhere. So all I have to figure out is where is that slope 0. So f primed of x is going to be 5x to the 4 add 9x squared add 1. Right? Now I had some people message me saying, I have no idea how to find where the slope of that is 0. Yes, you do. You have to dig back to your grade 11 skills and say, think of that as a quadratic. You might be going, well, that's not a quadratic. It's x to the power of 4. Yeah, but we can pretend it's a quadratic. We can say, we'll use the substitution method. Let u equal x squared. And then this thing is now 5, u squared plus 9u plus 1. There, now it's a quadratic. Even this didn't make my life very easy, though, because I'm going to try to factor it. What two numbers times to make 5 and add to make 9? There aren't any, so, okay, maybe that didn't help that much. So I do have another tool in my toolbox, though. I have the quadratic formula. So that'd be minus b plus or minus the square root of b squared minus 4ac all over 2a. So that's going to be minus 9 plus or minus the square root of 81 minus 20. There, I'll write it down. All over 10. So u is equal to minus 9 plus or minus the square root of 61 over 10. And I'm just going to leave it like that. Remember, first year university, you don't get calculators for things very often. So I'm going to just leave that in my exact form and analyze it. Now remember, I'm not actually looking for u, I'm looking for x. So u is x squared. So x squared is actually equal to this thing. And right here is where I can figure something out that's very important. If x squared equals this, then x would equal the square root of this. And what do you notice about this? Well, you notice that this actually has no solutions. Why doesn't it have solutions? Well, because negative 9 minus the square root of 61 is obviously negative, so you can't square root a negative. And even if this was plus root 61, well, isn't the root of 61 actually less than 8? So negative 9 plus a number that's smaller than 8 is going to be a negative. Both of these answers are negative, and you can't square root a negative. So what story is this telling you? Right? Something that's x to the power of 5, again, conceivably could change directions 1, 2, 3, 4 times. Right? It could, but it doesn't have to. So what this thing is actually telling us is that since no real x numbers exist for where the slope is 0, the slope is never 0. And you have no critical numbers. No critical numbers means no critical points. So if there's no critical points, what would I conclude then about this graph? Well, since I know it looks like this, where the left arm goes down and the right arm goes up, if there's no critical points for it to change direction, these two endpoints must be my minimum and my maximum. So that's what you have to do. That's it. Therefore, the endpoints are, that's an A, absolute, max, and min. And there is, in fact, no local max or mins. So you'd have to now, to finish this question off, find, right, it's bounded by negative 1 and 2. So f of negative 1 is, let's see, that's negative 1 minus 3 minus 1, which is negative 5. And f of 2 is, okay, what is that again? It's x to the 5, which is 32. 3x cubed is 3 times 8, which is 24. And plus 2, which is 58. So there we go. So my what does it ask for? Does it ask for absolute maximum and absolute minimum? There we go. There's my two values. So my two values are f of negative 1 equals negative 5 is my absolute min, and f of 2 equals 58 is my absolute max. So it took me a little bit of detective work to get there, but that's it. It's the endpoints that are the absolute max and min. There's no locals that beat them. And we can show that again on Desmos. If I just go back to Desmos, I have this one done. Here it is. And as you can see, right, it never actually gets to a slope of 0. It never flattens out enough to say it has a slope of 0. Okay, cool. Oh, and that doesn't mean it could. In fact, here, I did this. Let me just zoom out so you can see that the endpoints are on there. There we go. There's the endpoints. if the numbers here for in front of x to the 5 and in front of the x cubed were different than 1 and 3 and 1, it could totally be different. Here, I've actually got this so that I put sliders on these. So here it is if a is 1 and b is 3 and c is 1, which is just like the question. Notice if you change b, though, look what happens. You can get b to, there we go. Now we definitely have a point that would have a slope of 0, right? There'd be one right there. So we had to do the detective work to actually prove that that's the way this thing behaved. Okay, so all right, I'm gonna just go back and let's see, close that one maybe. All right, and yeah, we'll just leave that for now. All right, I was gonna do maybe one more if I have time. Oh yeah, we've got lots of time, right? What time do we go till again? We go till, no, 9:05. Yeah, I'll definitely have time for another bigger one. Okay, so another bigger one coming up here is this one here. Somebody asked me about 4.3 number 2. And this is actually a very big question. So it asks for a bunch of things. Find the critical numbers, the intervals of increase and decrease, and the local maximum values of the function. So it's asking for a whole bunch of stuff, and then it wants you to do a sketch. And this is why we gave you so many days to work on this homework assignment. Some of these questions are a lot of work. Okay, well, where do you start on this thing? Well, you start with the actual calculus. If this thing, it's a polynomial, I know an x to the power 4 has 2 arms that go up, but what happens in here? Well, it could change direction a bunch of times. It could change directions 3 times, potentially. So it could have 3 critical values. But those critical values happen when either the slope's 0 or it doesn't exist. There's no asymptotes in this thing, no cusps, so we just have to find where the slope is 0. So step 1 is we've got to find the slope. So the slope is 12x cubed minus 48x squared plus 36x. And where is that slope equal to 0? Well, we'll just set that to 0. All right, now, if we want to figure this thing out, the first thing we have to do is factor. And I have a common factor here of 12x, leaving me x squared minus 4x plus 3. Is that starting to look a lot better now? So 0 is equal to 12x times x minus 3 minus 1. And there we go. We are now in factored form. And there are 3 x numbers that will find us a slope of 0. So I have critical values, or critical numbers, whichever you want to call them, when x is 0, would make this a 0, 3, and 1. So 0, 3, and 1 are my critical values. But, okay, so, or critical numbers, so I've answered that part of the question. Now I have to find the intervals of increase and decrease. No, good question. Resist the temptation to divide both sides of the question by 12x. I know that makes it simpler, and it just leaves behind this, but then you lose this answer. X equals 0 is definitely one of the places where this graph stops and turns around. Okay, so that's a good strategy for when you're doing just basic algebra and you just want to get to x as quick as possible and you don't care if x is 0 or not. Divide both sides of the equation by x. But you never do that in calculus because x totally could be one of the solutions you're looking for. And in this case, it is. It's one of my critical values. I'm glad somebody asked that. Yeah, resist the temptation to divide both sides of the equation by a variable. Factor instead, it always gets you a better answer. Okay, I need an interval chart. We haven't done one of these since before Christmas, so here we go. Interval. So I have 3 critical values. I need to figure out what's happening to the left of 0, between 0 and 1, between 1 and 3, and after 3. Okay, I have 3 factors. I have 12x. Now the 12 doesn't matter, so I'll just say x. Right? The 12 isn't going to change whether you're positive or negative. I have x minus 3, and I have x minus 1. That'll tell me what the slope is doing, whether it's a positive or negative slope, and that tells me whether the function's increasing or decreasing. So Pick a number less than 0. How about -1, which will make that negative, 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 and a negative times a negative times a negative is negative, so we're decreasing. Pick a number between 0 and 1. How about a half? A half makes that positive, it keeps that negative, and it makes that negative. A positive times a negative is positive, so we're increasing. Okay? Give me a number between 1 and 3. How about 2? 2 makes that a positive, it makes that a negative, and it makes that a positive, so we're negative, so we're decreasing again. And what about the last one? When x is bigger than 3, that's a positive across the board, so we're increasing again. So we definitely change directions 1, 2, 3 times, right? Because we switch from decreasing to increasing here, increasing to decreasing there, and decreasing to increasing here. So let me kind of summarize that. At x equals 0, we're decreasing. We get to 0, then we're increasing. At x equals 1, we were increasing on the left, but then we're decreasing on the right. And at x equals 3, we're decreasing on the left, we're increasing on the right. So what do I know about those points? It said, where are how did it actually say it in the question? It said intervals of increase and decrease. So let's give them these things as intervals. So the function g of x is increasing from, let's see, so it's increasing from 0 to 1, I'm in interval notation, and from 3 to infinity. And I think the textbook uses interval notation too. They don't. You could do this in set notation if you wanted to. You could say, from there to there, right? But same thing. And then you'd say g of x is decreasing from negative infinity up to 0 and from 1 to 3. And there we go. There's the second part of the question answered. What are my intervals of increase and decrease? Now, local maximums and minimums, it actually doesn't ask for local minimum, it just says what's the local maximum. So, okay, so what's the local maximum? Well, the local maximum has to be this one, right? Because it's increasing on the left and decreasing on the right. So my local maximum is when x is 1, so I'd figure out what f, or no, it's not function f, it's function g, what g of 1 is. So g of 1 is, let's run 1 through the function, so that's going to be 3, 3 minus 16 plus 18 plus 1, so that's going to be 3 minus 16 plus 18 plus 1, which is 6. So there we go. My local maximum is 1, 6. All right, so that's the next part of the question answered. And what else did they ask us? So I've taken care of critical numbers, intervals, local max, and then just do a sketch. Now, if I'm going to do a sketch, I'm going to do the one thing that it didn't ask about. What about minimums? So I do have x is 0, so I have minimums when x is 0. And if you run 0 through the function, you just get the point g of 0 is 1. So 0, 1 is a local minimum. Oops, that's supposed to say local. And the other minimum happens at 3. So what's g of 3? So g of 3 is going to be, oh boy, I'd need a calculator for this. 3 times 81 minus 16 times 3 squared, 3 cubed, 27, plus 18 times 3 squared, plus 1. Charming. Oh, you know what? This is actually easy. 3 18s, this is actually 2 more 8. This is 3 81s, I should say. If you take this 18 and you make it 2 times 9, that's 2 more 81s. So it's actually 5 81s minus 16 27s plus 1. 5 81s is 405. Plus 1 is 406. And I know that 16 times 9 is 144. So it's 3 times 144. And what's 144 tripled? 288, did I do this number at some point? No, I didn't. 288 out of 432. So it's 406 minus 432. But don't worry, I'd let you have a calculator for a question like this. Negative 26, there it is. So my other local minimum is 3 comma negative 26. And I'd have to check with the endpoints, but that might be my absolute minimum. That's the other thing you should check, is you should actually run the endpoints through there as well. Because remember, this function was bounded, wasn't it? Oh no, this one isn't bounded. No, that's it. So that would be my absolute minimum, sorry. How do I know it's an absolute minimum? Because it's the lowest place it can go, and remember, an x to the power of 4, both arms go up. So there we go. I'm going to just show you what that looks like on Desmos, and then we'll call it a day here. Where are you, Desmos? Come back to me, Desmos. Oh, that's right, I closed it like a doughhead. Why did I do that? Okay, I'll open it again. Hopefully it doesn't take too long, because you guys got to get going. Come on. There we go. And there it is, homework, open graph, and it's this guy. And there it is. Oh, look at that. I even have kind of the settings kind of ready for it. There it is. So there's that local minimum at 0. There's my local maximum at 1 comma 6. There's my absolute minimum at 3 negative 26. So that's the sketch that I would have made. Now there's people saying, hey, wait, how do you know what the x-intercepts are? You don't. This would be something that would be actually quite difficult to figure out, because the original function doesn't factor with integer factors. So that'd be it. You'd just be kind of guessing. You know this arm goes up forever, you know that arm goes up forever, and the points you know are here, here, and here. And that's it. That's how you'd sketch that curve. So okay, so those are the ones that I picked because they were kind of based on things I wanted to point out and some questions that I had from students. All right, I'm going to run the attendance now, if I try to remember how to do that. It's somewhere in meeting actions. Guys who have to go to music, you can actually log out. It won't matter that you're not here when I do attendance. It's in here someplace. No, it must be in show participants. Download attendance list, there it is. My attendance has been downloaded. There, attendance is done. Okay, so enjoy the rest of your day, guys. We'll see you again tomorrow morning. If there's people who don't have music who have other questions, I noticed okay, I'm going to stop my video too. Class is over. Thanks for watching.